Okay, so we have done part 1 and part 2. Now we need to do part 3. This is part 3. Part 3 is De Morgan's law. Okay, so there's this mathematician called Augustus De Morgan. That is his name. I need you to find out more information about him. So De Morgan gave us 2 formulas that you will need to know for this lesson. And the 2 formulas you must know by their words. You must know by their picture, as in the Venn diagram. And you also must know how to write it in set notation or in set operation. Okay? So you must know 3 parts: how to draw it, how to write it in words, and how to write it using set operation notation. So the complement of the union of 2 sets will always be equal to the intersection of the complements of each set. What this says is you will put 2 sets together and find the complement of that. After you find the complement of 2 sets being together, this should equal the complement of one set and the complement of the other set, their intersection. Okay? So, the complement of the union. Union means put together. So like that. And complement. Then the intersection means you will find the intersection, but of the complements. Not of the sets, of the complements. These 2 should equal. And here is the picture. Okay? Here is the picture. Here is the set notation or the set operation. Okay? You have said it in words. You have written them. And there. All right. Let's do the second law. So the second law, the complement of the intersections of 2 sets will equal the union of the complements of the sets. The complement of the intersections. Find the intersection of the sets. Then find the complement. It will equal to the complements union. That means you find the complement of A, then the complement of B, then you find those elements together without repeating. Okay? And the picture, you draw the picture. I want you to draw this picture and tell me. All right. So we are using De Morgan's law. So let's say they gave you the universal set. These are the elements in your universal set. Then they told you what is A. Then they told you what is B. So now find A intersection B complement. First, that means find A intersection B. Then find what it is not. Okay? So A intersection B, I wrote my A. And I wrote my B. And I found what is in both. So that is A intersection B. Now to find the complement of A intersection B, I need to compare. Remember I told you, the minute you see complement, you have to introduce the universal set. Okay? It is the universal set minus A intersection B. Okay? So I wrote my universal set. I crossed out what is in both. So my answer for A intersection B complement is whatever I did not cross out, which is A, B, F, C, D. So I have done part 1. Now I want to do A complement union B complement. That means I need to find A complement, then find B complement, and then put them together without repeating. Remember I said complement means you're removing from the universal set. So I wrote my universal set. I wrote my A. I removed what is in both. What is remaining is FCD. I wrote it there. So A complement is FCD. I did B complement the same way. I wrote my universal set and I removed B. My universal set, my B, and I removed whatever was in B. And I was left with A, B, C, D. Now, to make union is I will put these two together without repeating D, because D is repeated in both. So I wrote it over here. See? A complement union B complement. What is in A complement and what is in B complement without repeating. So A complement is this, B complement is that, and then I write them together without repeating D. See? D is repeated, I will only write it once. Now, are they equal? So I brought this answer over here, and then I brought this answer from this work here. Okay? And are they equal? Yes, they are equal because the sets have the same elements. All the elements in here are the same. There is A in both, there is B in both, there is C in both, there is D in both, there is F in both. Even though they are not in the same order, they have, as long as whatever is in here is here, then it is equal. Equal means everything is the same. So that is what De Morgan's law is.